talking about adding, subtracting, and multiplying complex numbers. This is Unit 5, Lesson 2. And so a complex number is made up of one or two parts. It can either just have a real part, or it can have a real and imaginary, or it can just have an imaginary part. So you do not have to have both parts. And so the real is listed first, and then the imaginary. And again, you only have to have one of the two parts. So when you're adding, subtracting complex numbers, you're going to distribute signs and numbers and then combine like terms. You're going to write the final answer in the form of a plus bi. So let's look at simplifying. When we simplify, we're going to distribute that negative through to both pieces of the second parenthesis. And so you have 4i minus 1 minus 6i. So our real part is this negative 1. So I'm going to list it first. And then our imaginary is positive 4i minus 6i. So the real is negative 1. There's nothing to combine it with. And the imaginary portion, 4 minus 6 is negative 2i. That is your answer. So let's practice through a few of these. So this next one, we're going to again look at distributing that positive sign this time through. So when you distribute a positive sign, nothing changes. And so we have 8 plus 7 minus 3i. And so again, we're going to look at our real portion. So these two numbers make up our real portion of 15. And then our imaginary, which is negative 3i. So there's our complex number that we're left with. So let's look at number 3. This time we have both of them having both their real and imaginary portion. So we're going to go ahead and do the same thing we did before. We're going to first look at distributing any signs that need to be distributed. And so there's really nothing that's going to change when we distribute. We have negative 7 plus 6i. And since this is positive, everything's going to stay the same. So plus 4 minus 9i. And so when we group our real portion together, we end up with negative 7 plus 4, which is negative 3. And then when we group our imaginary portion together, we have a positive 6i minus 9i. 6 minus 9 is negative 3i. And so that leaves us with the answer of negative 3 minus 3i. Let's go on to our next one. Same idea, but this time we're subtracting two complete sets of complex numbers. And so when we subtract, we have to remember to distribute the minus sign through to the second parenthesis. And so we end up with 8 plus 6i. Nothing's changed there. And when we distribute that minus sign through, it becomes a minus 3, and that minus sign and the plus sign makes it a minus 2i. Now let's group our real portions together. And so our real portion is 8 minus 3, which is 5. And we're going to group our imaginary portion together. Positive 6i minus 2i. 6 minus 2 is a positive 4i. Let's take this next one. Same idea, but this time we're going to be distributing it through on that second parenthesis. So let's look at the operations. So we have that distributed through. So we have 12 minus 5i minus 4 plus 5i. And so when we distribute, we got there. So now let's combine our real portion. So 12 minus 4, which is 8. Now let's take our imaginary portion, negative 5i plus 5i. So that gives us cancels out, and that becomes 0i, which I don't have to write. So my final answer is just that 8. So it's okay for the real portion or the imaginary portion to cancel out. That will happen occasionally. And if both of them cancel out, the answer is 0. So let's practice with a couple of them where we have to distribute. And so taking it a step farther, this time we have to distribute a number through to that first parenthesis, and the positive is going to go through on the second parenthesis. So negative 6 plus 8i plus 5 plus 6i. So combining our real portion together gives us a negative 1. Combining our imaginary portion together gives us a positive 14i. So that's your answer. So now we have 3 things to combine. So it's going to work the same idea. We're going to take one piece at a time. So there's nothing to distribute here. The positive gets distributed here, and the minus gets distributed there. So 3 plus 2i, positive 4 minus 7i, and then that just becomes a minus 3i. And so our real portions get combined, so 3 plus 4, and then our imaginary portions get combined. Positive 2i minus 7i minus 3. So we have 7. 2 minus 7 is a negative 5i. Negative 5 minus 3 gives us a negative 8i. One more of these, and then we'll go on to the next type. And so here, we need to look and see what needs to be distributed. So we need to distribute the 2 to both parts of this parenthesis, the minus to both parts of this parenthesis, and the positive to both parts of that parenthesis. So 6 plus 2i, negative 4 plus 6i, positive 1 minus 3i. And so here, we combine like terms. Let's get our real parts together. So 6 minus 4 plus 1. So that's going to be 2 plus 1, which is 3. Now let's get our imaginary portion together. So plus 2i plus 6i minus 3i. So that would be 2 plus 6 is 8i, and then we have it minus 3i which gives us a positive 5i. So that's your answer. So now we're going to look at multiplying. So when you're multiplying complex numbers, there's two different things that can happen. You can either use FOIL, which was that first, outer, inner, last. And I'll show you an example where I do this. Or you can use the box method, where you multiply coming in, and so this times this equals 8. 4 times 3 equals 12. And we'll walk through how you do each one. But after you do it, you have to simplify your imaginary numbers. So you're going to have to use part of what we did the previous lesson, where you're learning that I squared is -1, and then multiply it, and then combine like terms like we did at the beginning of this lesson. And then you're going to write the answer in standard form. So let's just start with some basics. So this one, we don't have to use the box. 5 times 2 is 10, and the I gets written down. So before, you had to combine like terms, but just like with variables, think of this just like a variable. The way it would work is you ended up with 10i. So again, we're going to take the same idea. We're going to distribute through to both pieces. So -6 times 2 is -12. And then we just have one I. -6 times a -7 is a positive 42i squared. I squared is equal to -1. So that means we have 42 times -1. So we have -12i. 42 times -1 is -42. Now remember, the format we need to have it in is a plus bi. So this needs to go first. So -42 minus 12i is the answer. So just be careful on this, that when you're writing your answer, especially when you're going into the computer, that you go ahead and move things around. So let's look at using FOIL. So the outer is 3 times 5i, so 15i. The first is 3 times 2, so 6 plus, and then our inner is these two, so 4 times 2 is 8i, and then our last is 4 times 5, which is 20. I times I squared. And so we talked about that I squared is equal to -1. So therefore, 20 times -1. So let's rewrite it. So we have 6 plus 15i plus 8i minus 20. Now let's group our real and imaginary. Our real numbers, 6 minus 20. Our imaginary numbers, plus 15i plus 8i. And so we end up with a negative 14 plus 23i. So using the box, you're going to end up writing the multiplication on the outside. But first off, let's look at what this is, what this means when I have a squared. So that's 5 minus 2i times 5 minus 2i. And so I'm going to put them on the outside. So 5 minus 2i, 5 minus 2i. And so when we multiply in, that gives me 25. Multiplying in, 5 times negative 2 gives me a negative 10, and I just have one I. 5 times negative 2 gives me a negative 10i. Now in this next one, we have and so we are going to multiply negative 2i times negative 2i, which gives us a positive 4i squared. So I squared is negative 1. So 4 times negative 1 gives us a negative 4. If I can get the right color. And that was a real number. So our two real numbers combine, giving us a positive 21. Our two imaginary numbers combine, giving us a negative 20i. So let's do a couple more like this. We're multiplying two complex numbers, 4 minus 3i and 4 plus 3i. For this one, I'm going to use the box method. It really doesn't matter if you use FOIL or the box. Both work just as fine. The box method just gives a more visual way of working through it. I'm going to put 4 minus 3i on the top and 4 plus 3i on the side, but that doesn't matter which side you go with. So 4 times 4 is 16. 4 times negative 3 is negative 12i. 4 times positive 3 is 12i. And 3i times negative 3i is negative 9i squared. I squared, as we talked about in the last lesson, is negative 1. So negative 9 times negative 1 is a positive 9. We're going to add together the real numbers, and we end up with 25. When we add together our imaginary numbers, 12i plus a negative 12i, they cancel out, leaving us with 0. We don't have to write the 0, but it is just 25. So let's look at number 14. 14 is slightly different. We have a real number in front of the first complex. And so what we're going to do is we're going to distribute that real number of 2 through to that first parenthesis. And then that's going to be our new first parenthesis. So 3 times 2 is 6. 2 times 4 is 8. And we have that I, so 8i. So our first parenthesis is 6 plus 8i. Our second parenthesis, we didn't do anything to, so it just comes down. We're going to write 1 on the top and 1 on the side. Doesn't matter the order. So 1 minus 2i, and the other one is 6 plus 8i. So 6 times 1 is 6. 8i times 1 is 8i. 6 times negative 2 is negative 12i. 8i times negative 2i is a negative 16i squared. As we just talked about, I squared is negative 1. So 16 times negative 1 is a positive 16. When we add our two real numbers together, 6 plus 16 is 22. When we add our two imaginary numbers together, 8i plus a negative 12i gives us a minus 4i. So that product is the complex number of 22 minus 4i. Number 15, instead of a real number that's in front of that first parenthesis, we have an imaginary number in front of that first parenthesis. So we're going to distribute that 5i through to that first complex number of negative 7 plus 8i. When we multiply by an imaginary, you're going to have to work with simplifying the parenthesis before you go further. So 5i times negative 7 is negative 35i. 5i times a positive 8i is a positive 40i squared. I squared is negative 1. So positive 40 times negative 1 gives us a negative 40. Bring down the negative 35i. And this is in the form that we need for complex numbers, a plus bi. We need to switch around the real and imaginary parts to get it in the correct order. When they switch places, their sign travels with them. And so that would be negative 40 minus 35i. The other complex number that we're multiplying by doesn't change. So we're not doing anything to the 2 minus 3i. We're going to write 2 minus 3i on one side, and we're going to write the negative 40 minus 35i on the other. So 2 times negative 40 is negative 80. Negative 40 times a negative 3i is a positive 120i. 2 times a negative 35i is a negative 70i. Negative 3i times a negative 35i is a positive 105i squared. I squared is negative 1. So positive 105 times negative 1 gives us a negative 105. When we add our two real parts together, we end up with a negative 185 plus 50i. And that's your complex number. Number 16, you're going to do on your own. You have to remember to distribute the 7 first to the first complex number, and then multiply, and then check your answer on Wayground.